So this video series is going to focus on people who want to create their own recipes. And in order to do that, you need to be able to create your own inserts. And before we get started, let me mention a couple things. First of all, there's this SYNTH video manual, and I highly recommend you take the time to look through this. If you look through the description, you've got a clickable list, and all of these chapters in this video manual are really important that you understand. So definitely, before you start to create your own recipes, go through this video manual, and that's the KidOps SYNTH video manual. And also, you need to go through the KidOps video manual itself, the regular one, and it also has a list. And in particular, I want you to look at these chapters, starting anatomy of an insert, and then all the way down through save insert button. So these chapters right here are critical that you understand. I'm going to assume that you already know most of this other stuff about KidOps. So these two video manuals are imperative that you spend some time with before you jump in to try and create your own recipes. Okay, let's talk about materials for a second. Included with KidOps SYNTH is this new KO FreeMats master folder.zip. And if you unzip this, you're going to get this folder, KO FreeMats master folder, and you double click in there and you'll have a set of emissive materials, metal materials, plastic paint materials, and special mats. And these are materials that are set up to work with SYNTH. You really should not modify these materials at all if you're creating inserts for any sort of K-Pack, whether it's KidOps or SYNTH. And the reason for that is that we want you to be able to add these kinds of materials to any insert, and it'll automatically fit in with other insert collections. And it'll also allow people to change one material and it can change a whole look. So for instance, if you have a corridor, you change one material in the corridor and all the other materials change. Let's take a look at that. Okay, here we are in a corridor created with SYNTH, and we have these same materials used to create this corridor. Let's take a look at what we're talking about with regard to how we can use these free materials to make global changes in a SYNTH generated object. So I'm going to turn on my overlays and click here, and you see we have this SY dark matte, and each one of these SYNTH materials has a node group, and this dark matte has a color, and I can click on it and I can just change the color. And so everything that was created and generated with this dark matte material can be adjusted at once. Let's go over here and let's click on this steel material. So you can see as we move in here, this steel material, we might want to make it a little more reflective. So we'll come in here and we'll turn the roughness down just a little bit. And now we've made it all more reflective. And it doesn't just affect this rail, it affects all of these other parts that have the same material applied. And so that's the reason why we want to encourage you to use the KidOps free materials. And of course, they show up here as KO emissive, KO metal, KO plastic paint, and KO special mats. Okay, now let's talk about something else. And what I want to discuss is the concept of bounding boxes as the main object in an insert. And let me show you what I'm talking about. I'm going to basically, this is a brand new scene. I'm going to say A, X, delete everything in the scene, including these. And I'm going to just say Shift A, cube. And now I'm going to basically go in and say save as, and I'm going to find a K-Pack folder that I'm already working in. I've created a master folder called Chips Working, and I have this test, and I'm going to call this one Bounding Box Demo, and we'll save that. Because we saved it in a K-Pack folder, KidOps now automatically goes into factory mode. And what I want to show you is how the bounding box affects the placement of the insert. Let's go ahead and say Shift A, mesh, and we're going to add a cylinder in, and that's our cylinder. There's our bounding box. So let's take our bounding box and we're going to turn that into a wire. So what is a wire? Well, a wire is a placement object. It doesn't render, but it's used to place things. It's always the main object. The cylinder needs to be parented. Obviously, we need to parent it. I can say auto parent and save insert, and the cylinder will be automatically parented, but typically I manually parent it. But that's fine. So I'm going to take this cylinder now, and I'm going to say shade smooth, and I will go into the normals and auto smooth it. And then I'll go in and I want to add a material to it. So for this material, we're just going to say a new material, and I'll make it blue. And that's it. Now I'm not using these free materials, as this is not going to be an insert that I'm going to publish. So now that we've done that, let's take this cylinder and let's scale it down just a little bit, and we know that it's a solid. So let's go ahead and save this insert, and what I'm going to do is open up a new instance of Blender, and here we have it. I'm going to go to KidOps, and I'll go into test, and here I'm looking for that bounding box demo. I did not create a thumbnail, and with it said, I'll go into medium 50%, and I'm going to just add the insert here, and you can see how that's supposed to be added. I'm gonna hit the escape key. Now I'm gonna tab into this, select this top face, then go into Synth, and I will do the same thing. I'm gonna find test, choose the bounding box demo, and my placement style is gonna be grid 1-to-1, so it's gonna actually expand to fill the whole thing. And then I'll say do it, and you'll see that's exactly how it works. So notice the bounding box expanded to fit everything. Now if I go down into my transformation, I have a padding. If I add like 5% to that and say do it, it's going to shrink it because it put the padding around it. Now let me show you another thing. Let's go back into here, and I'm going to take this and I'm going to move him out. So if I look at from the top view, I'm going to just line them up like this. And then I'm going to save the insert, and then I'll go back here, and I'm going to take this insert and X, delete it. Actually, I could have just used the clear button as well. And I'll say do it. And notice that what happened is it put this on the edge. So it's using the bounding box to place the insert, and whatever's parented to the bounding box is going to be moved relative to the center of that bounding box. So keep in mind that when we use this bounding box, the origin of this bounding box is going to be the placement point for the insert. The origin of the parent object is always the placement point of the insert. So let's talk about why this bounding box is important in our recipe creation. And many of you have seen the corridor example, and it uses bounding box a lot. In fact, what's really interesting about this particular recipe is it uses a 1-by-1 grid for almost everything that it does. So let's walk through this really quick and show you what I'm talking about. So I'm going to turn off everything in here, and I'll hit do it. Basically, we just have a box, right? If we tab into it, you can see this is what we have. Let's hit the do it button with just the cut all turned on. And what happens? It just completely disappears. So you can see that the box is no longer there. So what did we do? Let's go take a look really quick at the cut all. So I look in the cut all, and basically it's just a cube. It's a very, very long cube because I'm assuming that someone may want to make a very, very long corridor. So this cube is just a tiny bit above the XY plane. And as we know, all of our inserts are placed normal to the face that they're being selected to. So all of our inserts are created with the notion that they will cut or add material to the Z axis. So keep that in mind. So I'm going to turn this into a cutter and a difference, and let's go back to our scene, and you can see that in fact the cutter cut directly from the face, which is over here, all the way through the object, and even further because this is actually showing the cutter. So if I clear it, you'll see that that's the cube that we're starting with. And if we look at that cutter, we'll see that it's set up to be a grid at 1-to-1, and it's also set up to have a padding value of -0.1. So instead of padding on the inside, it's padding on the outside, and that's why it cuts through the whole thing. Okay, so now we'll do it again, and I'm going to add this hull. We have a lot of different hull designs. Let's use hull 1, and I'll just turn off the others. Now after pressing do it, we have the cut all, which cuts everything apart, and then we have the hull, which actually adds to. So let's look at our modifiers. We have this difference modifier, which is the very first one that cuts away the entire cube. And then we have this union modifier, which is actually unioning from the cutaway cube. So that's how we create the basic hull. Let's go in and take a look at the hull insert and how it works. Okay, so when we open up the hull 01 insert, we're looking down from the top again, and you can see we have this orange object, which is just a wire. And I put X's in there, but you don't need to. It can just be a bounding box. It doesn't matter, but it's a wire cube. It's our main object, and it's our placement wire. And then if we look at this other object is placed a little bit inside and a little bit outside. But the key part of this one is it's also a cutter, but we're using this as a union, not as a difference. And another thing to point out is this bounding box wire placement object is the exact same bounding box wire placement object in every single one of the hulls, as well as every other single element in the corridor. So everything is placed with respect to this bounding box wire placement object, and that's critical. So let's go back to the main scene and let's talk about how this is placed inside of Synth. Here we are, and we can take a look at this. Let's first look at the cut all. We talked about this earlier. It's just a grid 1-by-1, and as we mentioned, it's got a negative padding, so that means it goes outside of the original cube, and you can kind of see that right here. If you look in here, there's the original cube right there, and this is the cutter. So it actually goes outside. It deleted everything as we talked about earlier. Okay, now let's look at the whole object. And as we look at this, we're going to see that it is also set up to be a 1x1 grid. The padding's on the inside. The key part about this, and actually about both of these, is that notice this button is turned off. So maintain aspect ratio is turned off. If I turn this on and say do it, it's going to keep the same aspect ratio that we had in the original insert. We want this recipe to be flexible and to size based on the cube that it's being applied to. We'll turn it back off and say do it. So the same thing is true, of course, with our cut off. We have the same thing here set up. Another thing I'll point out is in the hull layer in the transformation, we have scale Z plus at 100%. So that means that it's going to be twice as long or deep as the original insert. And this is because we didn't want to make the original insert too long, because we might want it shorter corridors. And as long as we stretch all of the other inserts, we're going to be fine. So one last part about the bonding box that I want to talk about, and that is, let's go in and let's look at the rails. This is a good example. And I'm going to basically turn that on and say do it. And notice the rails are right there. So let's go look at this particular rail. This one is handrails 02, and we'll take a peek at that now. Okay, now we're looking at that insert, and what you can see, and what's important to notice, is that this placement wire is the exact same placement wire as we had previously. But all of these other parts are moved in substantially from the right and from the left, because we want them to be placed further in on the corridor and not at the edges. So again, we're using this placement wire to provide us a bounding box for the insert, and then we're putting the inserts at the place we want them to be with respect to the bounding box and the corridor interior. So if we go back, we can see that that's exactly what's going on. And if I adjust the actual cube, this box, to be even longer and say do it, everything's going to stretch and match the proportion of the original cube. So let's take a look at this bezel recipe. I think there's a lot of things that we can learn from it. So I'll load recipe, I'll go into the 2U rack mount bezel JSON, and it loads up, and I'll tab into this, make sure my front face is selected. And I'm gonna first thing, just hit this do it button. And so what it did is, it has a cutter that goes off really a long way just to make sure it's gonna cut through everything. And then it has a faceplate. So let's turn that off and let's clear and show you what I'm talking about. So we'll do it. There's the cutter, turn on the faceplate, and it just has one object in here. And this object comes in perfectly scaled. See this little button that says don't scale. So it comes in perfectly scaled. And the reason for this is that we know that rack bezels are 19 inches wide. And so this is set up to be exactly 19 inches wide. And so in this particular recipe, we're saying to do these things first. So all the number ones we do first, and says then bake. So then we go to tools and we say bake object, remove wired inserts, and here we have our object. Then what we do is we're going to go ahead and do the next stuff. So I'll go to surface distortion and I'll say do it. We're going to have to actually go into here and select that first surface and then say do it. And now we've added another cutter to this object. And the cutter that we added is this S rack mount. Let's just put auto update on it, and let's just iterate through a few others just to see what we have. So you can see we have 1, 2, 3 different versions. I can just turn these all off. We also have a blank version. So if I just turn them all off, you'll see that that's the blank version. Here's another version. Here's another version, and there's another version. So I turned all 4 of them on, of course. Placement style is set to grid. You can look through all this, and I can just, work through them, auto update all day long. I am going to talk a little bit about the cutter, this particular cutter that we're using. And that cutter is the Surface 2 cutter. So let's go take a look at that. So here we have the Surface 2 cutter, and what we have are 2 meshes. The main object is actually a cutter of difference. And when we look at that from top view, we will see that that's actually a little bit inside the other object. And the other object is cutter union. So the way this works is this cutter will first cut into the object, and then this union will add to the object. There'll be 2 different Boolean operations. One will cut in and one will union. So how does KitOps and SYNTH know what order to add these? It's actually simpler than you might think. It will look at the name cutter and X cutter and it'll alphabetize them. And the one at the top will be used first, and the other cutter will be used second. Let's take a look. So if we go into this object and we look at its modifiers, we see that we have this one at the top and the one at the bottom. So we have a difference and a union. So that's exactly how it works. And this is the X cutter, and this is just called the cutter. This is the X cutter, and this is the cutter. So there are a couple interesting things to note about this design. So let's look at the top view. I'm going to tab into edit mode and show you that there are only 8 points on this box. So that makes it extremely easy when a Boolean is cutting into a object. It's only going to cut in with that cube, which will then make it very easy for multiple Booleans to be added to the same object. Now, if this was a circle, if this was a cylinder like this, then you can see that we're going to have to cut into the surface, and we're going to have triangles coming out from every single one of these vertices. And that's going to be a very difficult solve for the Boolean engine in Blender. So when at all possible, try and minimize from the top view the number of vertices that you know that you're going to have to be using in order to cut into the target object. So I'll show you something else that's very interesting, and that is if we take our object and we stretch it in one direction, you'll see that the actual object, and I'm going to turn this into solid so you can see it a little better. It still looks like a pretty reasonable object as we're moving this main object. So as it gets stretched, it's going to look pretty reasonable. We'll reset that. And then I'm going to take this cylinder and I'm going to go ahead and add it to this object. And now when we start stretching it, we start seeing that the cylinder gets deformed quite a bit. However we stretch it, we're going to get a deformed cylinder. And so that's something else to keep in mind. If you're going to create an insert that you know you want to be able to stretch in the X and Y view, top view, then you're not going to want to use circles. Because when stretched, circles are going to look just like that. They're going to look like something that's been stretched. So if you look at here in the side view, you can see that even if we stretch this up and down, even though that we have like radiuses here, they still work pretty good. And even if we squinch it this way, they work well. So when you're building your objects, keep in mind that those radiuses will work well in the X and Z direction and the Y and Z direction. Just don't use them as much in the XY direction because you'll see those stretch very quickly. So why would we make this a union? So why would we make this a union instead of a cutter? Well, there's a couple reasons. One is that by making it a union, it's going to be part of the target object. So if we do anything to the target object, it will also do the same thing to this particular cutter that we're adding. So if we add a modifier, like a bevel modifier, that will be affected. If we use something like KitOps bevel to add a normal bevel, that will affect this as well. And in that sense, then, we don't want to add too much detail to these kind of cutters. So a good rule of thumb is if you're going to use a union, don't add that last bevel detail, because you're going to want to add that after this insert has been applied, and then you're going to add the bevel modifier or change the material or something like that. So if you're creating an insert with a union cutter, keep in mind that you want it to not be as finished as you might expect it to be if it were a solid object, because a solid object is a separate object and it's not going to be unioned with the original target object. Another thing to notice about this particular one is that notice this union actually goes up above the main surface that we're dropping this into. So unions are great for adding volume outside of the target object. That's something to keep in mind. So let's create a desktop surface. And the way I'm going to do that is I'm going to start off with this cube and I'll select this front face. And the first thing I'm going to do is I'll go into actually let's delete this layer, add a new layer, and we'll call it do first. And then we'll add another layer and we're going to call that one cut all. And I will go into corridors and I have a corridor cut all right here. And if I just say do it, it's going to cut it, but it's going to cut it in rows. And that's because placement style is set to rows. So I'll use grid and then I'll say do it. And now it cuts it, but it leaves just a little bit off. So I'm going to go right into my transformation and my padding. I'm going to say -0.1 and then I'll say do it. And now we're in pretty good shape. So the next thing I want to do is I want to create a desk surface. And to do that, I'm going to Shift A and create a plane. And then I'm going to GZ and I'm going to move it up And I know that a good desk surface is about 27 inches up. So I'm going to type in 27 inches, and that's going to move it like that. And then I'll look at my object here under item. I'll see that my Y dimension, my X dimension, I want that to be 48 inches. 48 inches. And I want my Y dimension to be about 24 inches. And that's going to be basically my desk surface. And then I'm going to tab into that, and I'm going to extrude down, and I'm going to go down about an inch, minus 1 inch. And that's our desk surface. And now with that said, I'm going to go into my kit ops, and I'm going to choose my plastic paint, and I'll give it a dark matte and add the material to that. And with that said, I'm going to go ahead, and I always power save first before I leave, create an insert, and here's our insert. I need to make sure and save the insert, and I'll hit save insert, desk, and I say save insert, and then render the thumbnail. There we go. And then we'll close the factory scene. And now we're back here, and now I can delete this. So the next step here is I'm going to go into SYNTH, and I'm going to add another, and I'm going to call this one desk. And so I'm basically going to create that. I'll go into my test folder, and in here I'm going to look for that desk, which is right there. And I am going to say, I'm going to make it a grid also, 1 by 1. And now when I do it, watch what happens. I'll select my box, and I'll say do it, and you'll see that it comes in the wrong way. And the reason for that is that, remember that we're always going to apply things normal to the face that we selected, and if you recall, that's the face that we selected. So what I'm going to do at this point is I'll go ahead and save my file. I'm going to go ahead and save it as desktop 01, and with it saved, I'll go to another version of Blender, and I'll open up that insert, and there it is. And so what I want to do is I'm going to want to make sure that insert is rotated about the x-axis, RX, make sure it's at 90, it is. Control A, we're going to basically all transforms, so it's going to be set there. And then I'm going to basically drop it down to the middle, so I'll say tab into this, A, G, Z, and I'll drop it right down like that with absolute grid snaps, so I know I'm accurate, and tab back out. And now I can see that the insert point is right here. And one other thing I'm going to do when I'm over here is I'm going to make sure this is a cutter union, and I'll save that insert, and I'm going to go back over to the original, and I'll select, with the box selected, I'll say do it, and there it is. And now I'm going to go ahead and expand this a little bit and say do first, then bake. And with that done, I'll go to my tools, and I'm going to bake the object and remove unused wires. And now this is our box. And at that point, and so next thing I'm going to do is I'm going to populate this desk with a keyboard. So I'm going to add, do next, turn this off. Also, I'll go to do first. Do first, I want to make sure that that's turned off too. So we do first. These labels, we just don't want anything selected, is really what I'm saying. Do next. I'll call this to keyboard. I'll go into this object, I'll tab, select the top surface, and I'll go into S scaled, and in here I have a keyboard with trackpad. I'm going to add that, and if I just say do it right now, we'll see what happens. So you can see that it inserted 6 of them, which is not what we want. But also you can see that it rotated them. So let's do a couple things. Let's go to our grid, and we're going to set that up as, or let's do rows, and we're going to set it up as a 1 row. 1. On the rotate, I'm going to rotate it 180, and I'm going to scroll back up and say do it again. Okay, so now nothing happened. And why is that? Well, we have 1 row, and this object is trying to scale itself into the 1 row, and it's just not working. But if I go over here and I say I want to make sure I don't scale this, and say do it, then it's going to work. So that's the actual accurate scale for the object, and it put 4 of them in. Now I want to click here and say I just want 1 of them in, and there it is. And then I'm going to go down, and I'm going to say I don't want it at the top, I want it at the bottom, and I'm going to say do it. Oops, wrong direction. Maybe I want to go, yeah, let's put it at the bottom. Let's put it at the top and say do it. And there we have, and there's an actual keyboard to scale on our desk, or it's actually embedded into the desk, as you can see. And then I can do other things if I want. For instance, I can go ahead in here and add some other items. So let's go to, let's populate this to scaled. And let's add, actually we're going to do a S assemblies, and I can just start adding a few different things here. This one, I want them to be also scaled correctly and used only once. And then let's go into here, S assemblies, one of these, and let's hit do it and see what happens now. And you can see that we have a few more things going on. This one, we forgot to turn on the scale. Okay, so now we have a few other things, items being placed in here. You can see some of these look to be out of scale. So I'm going to take this one, and instead of don't scale, I'm going to make it 50% and say do it 20%. So I'm adjusting it, and you can see that's probably more accurate. And this one looks to be about the right scale. So that one just is a little bit large. And then I might want to also add some, I'll add some cutters as well. Let's add this pad diagonal right here. And we're going to let this just resize itself so it'll fit. So I'll say do it. And you can see that the pad diagonal did resize itself nicely. And now what I want to do is just start with the auto update on, just start reviewing a few of these at a time. Actually, that one looks pretty good. So this one right here is kind of the one that we're going to want. You can see we have this big hole, and the reason for that is because in our optimizations, we want to say exact. Okay, so that's good. So now we have this set up. It's got these kind of drawers on the side, which will be fine. We can always modify those later if we want to, but that's a good start. So the next thing I want to do is I want to populate the back a little bit. I'm going to save this, start with a new scene, A, X, delete everything, Shift A, mesh, tab into this, E, move it down, and then A, Shift N to make sure that all normals are calculated right. Q, face orientation, we're in good shape. We'll go to kit ops. Let's add a material, something like plastic. Okay. And with that set, then the next thing I want to do is I'm going to add, for reference, I'm going to add a scaled computer, the large one. And I'm going to turn off auto scale, add the insert. I'm going to stick it over here just so I know what it looks like. Okay, then I'm going to go in here and I'm going to add a cutter. I've got some different ones in here, but I think I'll take this one and I'm going to add the insert here, and I'm going to make it at 0, 0. And then I'm going to scale it down to where I know some of this stuff will fit it, like that. And I'll take this, delete it. I can now take this and go into kit ops and just say convert to mesh, remove unused wires. So now we have that as a mesh. Tab into this and just select these faces. And I'm just going to go into, I'm not really creating a recipe here. I'm just going to go in and start adding some stuff. So I'll go into scaled, find my 17-inch monitor, placement style is grid, and just say do it. And look, it sticks it right in the middle. Let's also, let's make that a row. We'll make it one row. We'll add into that some assemblies, maybe something like this. And we want those to be scaled. This one automatically scaled to the size that that it wanted to, right? We just set that up to scale, keep the proportions. This we can probably say do the same thing, say do it, and let's just auto update that, and let's kind of keep moving, something like that. So we've got some rather big switches. We might make this, 50%, and now we have two banks of switches. That's a little bit more reasonable. And then once we have this done, this is going to become an insert for us. So how do we do that? Well, we'll select this and we'll just go into the tools and say bake object, remove unused wires. So then we just go into this object, we'll tab into here, and I'm going to go one, I'm going to just take that and this. All these vertices here, I'm just going to delete these. and that leaves just this. And this is going to be my insert. Top view. Okay, I have these 4 vertices selected, and I'll just say P and move them to its own selection, which is right here. Tab out of that. So this is fine. Now I'll go to this, and I'm going to basically isolate that, tab into it, and say A, fill, and then E, move it up, and then A, and then Shift N, because we want to make sure that we've got these normals facing the right directions, even though it's a cutter. And then we'll go back out, and we'll see that there's our object right there. There's our object down there. So I can just tab into this. I'm going to move it down a little bit. We can kind of see where we're going. So it's going to cut into the surface, something like that. This needs to go down just a little bit lower than that. And now all we need to do is file, save as. We're going to save this in our test. We'll call this one monitor station. I can go in here and let's go into KitOps. Make sure this is our main object. This right here is. And then select A, Q. We're going to basically say objects. So everything's selected. Control A, all transforms are right in the middle. So now we should be in pretty good shape. We should have all the stuff that we need, other than this is going to be a cutter. That's a difference cutter. I'll just leave it like that. I'll do save the insert, and I'll load the render scene, camera to insert. Let's go ahead and lock the camera to view, move it around a little bit so we can see what we got. And we'll say render thumbnail, file, revert. Okay, and let's go to the top view just to make sure everything's right. So notice that everything's not right. Need to rotate it 180 degrees. We'll save that insert now. Now let's go back to our original, and here's our desk. And what I'm going to do is I'm going to take this keyboard, and with auto update off, I will duplicate this. I'm going to call this one monitor. With that, I'll go and move all this stuff to, instead of the top, I'll move it to the bottom. And I need to make sure that everything is scaled properly. So I'll turn off all of these, go into test. There it is. I'm going to set this as a grid, and I want it to be top, as we said. And we'll say do it. There, I put it 100%, and I put do it, and you can see what it did. And I think what I want to do is, I don't think that I want it 100%. I think I want it maybe at something like 50%. And then I'm going to, I'll go to rows again and say do it. There, we have a bunch of monitors up here, but in my case we only want one, and let's make it 80. That actually looks pretty good. So we can call that a desk recipe, and we're going to save the recipe, and we're going to call it desktop 05. And that works pretty good. So that's an example of how to create a quick desk recipe. Let's go ahead and replicate this now. File, new, general, tab, click here, and we'll go into SYNTH. I'll go into recipes. I'll load the recipe. Okay, now with this set up, I'm going to select that front face, and I'll say do it to get the first part done. And then I'll go into my tools, bake object, remove unused wires, tab into this, select that. Let's go get the next part, these 3, and we'll select our object and say do it. And there we have it. And let's see what happens when I auto update this with a couple different ones. So you can see it's going to move things around on the bottom. There was really nothing to change on the top, but you can see we're starting to get some other different kinds of setups. And you can keep doing this as you want to move things around and get them where you might want them. But you can keep iterating through this. And there's another one that we might like. And we might create different configurations over here and maybe some over here as well. That should give you an idea how you can use SYNTH to create your own recipes. Okay, so let's turbocharge this recipe a little bit. First, what I'm going to do is I'm going to work on the lower layer, which is the keyboard layer. And what I'm going to do is I'm going to change this. Let's go back up here and leave auto update off. I'm going to change this so that it's the golden H panel. And I'm going to make the scale of this 18%. And now let's do it and see what we get. So now you see what we've got. We've got all these little boxes around here. And I can turn auto update on, of course, and I can start moving around. Maybe we like something like this. We'll see. Now that I've got this done, let's go ahead and switch to the monitor level. Turn off auto update, and here we'll go in, and with assembly selected, let's choose this switch VO1, make the scale 100, or actually let's just use the accurate scale, and let's hit do it and see what happens. There we go. So we're moving things. So we've added a little switch to that. Let's add another insert, and this time we will use the cutters. And let's just grab, I don't know, this one, this base desk. And I'm going to turn this off. And I'm going to scale this to 80%. Leave it like that. And let's hit do it. And now you can see we're starting to add a lot more complexity to our desktop surface. And I can save this as another recipe. And then once we have this done, I'm going to go ahead and use Iterator to generate a lot of different versions of this. And I'll come back when we're done with that, but first let's go from 0 to 50, and I'm going to store them, create a new folder, and we're going to call it desktop, and accept that folder. And now I just need to make sure that my screen looks good, and it's not quite lock camera to view. Let's move it into something like this. Okay, that looks pretty good. I'll just power save this, and with my box selected, we'll hit the start button, and we'll be back when we're finished. Okay, so that took maybe 10 minutes or so to render out, and let's take a look at what we have. And I'll just kind of walk through these, or step through these one at a time. You can kind of see. And when I see something interesting, I'll kind of pause, and we can stop and take a look. That one's interesting because the keyboard is near the monitor. I think the keyboard being near the monitor is going to be important for all of these. Here's another one. I like that one. The keyboard is directly in front of the monitor on this one. That's pretty cool. Here's another really nice one. That one is number 12. Might be the best one so far. That's good too. That's 25. That's got the keyboard and the monitor more or less in the middle. And I like that as well. That's 31. That's 37. .48. It's kind of interesting. And that's it. So let's go to number 25. Here we have our object. So I just click on here, enter in 25, hit return, and say do it. And that's our number 25. So I hope this helps explain how to use recipes to create your own synth iterations. Stay tuned for the next installment of the Synth Recipe Handbook Volume 2. Thanks for watching. See you online.